Greetings programs, welcome back to Stegosaurus Studios. My name is The Shop, this is Mike, and we're going to do everything backwards today. No, we're not. Alright, so this is Pit Droid episode number 6. We're going to move on from the head movement, and we're going to start talking about wrist movement. So there's a lot to get to, so let's get on with it. Alright, so I recorded a video yesterday and I forgot my lapel mic, and I didn't give any backstory or explanation of what was going on, so it was a little rough. I was a little overexcited. So go ahead and watch that and then come right back. Okay, watch it. Hey there. So this is it is the jury rig of all jury rig setup on this, but it does prove the joint concept. So this is a 2-axis joint that was weeks of work, almost a solid week of infusion to get that designed and then printed. This is a mess. But basically these pulleys, if you know what a Bowden tube is, a Bowden tube, we're all familiar with it from brake cables on our bicycles. And so this is simulates that. And it's actually 100-pound test fishing line running through PTFE tubes. And there's 2 lines that go to each axis or each direction, forward, back. And one is wound one direction, one is wound the other direction around the pulley, so that when you spin the pulley, they move back and forth. And I'll actually demonstrate this now. So this one is the forward back, and this one actually is pretty good right now. There's a little bit of backlash because there's a little bit of looseness, but generally speaking, I'm very happy. It's moving the joint, as you can see. The hand is going back and forth. This one has a lot of backlash. It's a mess on this side, but it does work. As you can see, the hand is moving back and forth. Properly tensioned, there should be 0 backlash, and so I'm pretty happy with this joint. I'll do maybe a second video where I actually talk about how this joint operates. So, because I didn't, and I know I'm skipping over some stuff here, so we'll cover that in future episodes or future videos, hopefully in this episode. All right, you're back. Did you watch it? Okay. So let me tell you what the heck's going on here. These are the files, as printed. You guys, and I've talked about these. So the wrist joint, in the current design, it can spin like this, but it has no ability to wave, and I've talked about that before. So this is it's like the second attempt at this joint to give it some motion. So this is a 2-axis joint, so there's bearings here and here, and that allows it to go this way. And then there are bearings going the opposite, and that allows the hand to go side to side. So I got this initial design from Hex Robotics. Check him out on YouTube. The joint that he demonstrates that I was looking at is actually that I was starting from is a differential joint. So a differential joint, you need to operate 2 motors at the same time. If you operate them in the same direction, the wrist moves one direction, and if you operate them in opposite directions, the wrist moves in the other direction. I did not do that. I operate it just one at a time, and you see all these strings here. I got the idea for fishing line. This is a 100-pound test fishing line from another YouTuber, Row Technic.
He has a 6 degrees of freedom robot arm that utilizes this technology. As I said on the video, it's Bowden tubes. So this is a PTFE, 4mm PTFE tubing, 100-pound test line that moves in the middle of it, just like a brake cable on your bike. And so let's dive into the anatomy just a little bit. So I didn't print out the whole forearm. I cut a section of it, and so the threads go, or the fishing line goes up and through the bottom here. So the side to sides, the fishing line path actually goes up and goes into the side bracket and comes out right here, and then ties off over here. Same thing on this side. It comes in the bottom, goes through this bracket, and comes out here. And so as you tug those back and forth, that's what gives you the side to side motion on the hand. The other two lines, this one, which you can see coming up through here, it comes up, it goes over the top of a guide bearing, and it ties off onto the back of this cradle right here. The other one goes the opposite direction. It comes up the back side and then ties off here to the front. So similar to the side to side, it's pulling this rectangular cradle either this direction or this direction, which is making the hand move back and forth. So that's how it operates. So I actually have these, I have the whole forearm, imagine forearm, with the Bowden tube holes running all the way through. I just only printed the first section. I'm going to print a full-size one. The reason I didn't print the whole thing is I haven't done anything with these paddles on the other end. I need to redesign the whole elbow. And actually, since I have this in my hand, let's talk about this point. These arm pieces, the upper arm in particular, there's so little space. If you were to like open this up and look inside, and there's not very much space in here. You really can't fit any sort of motor inside this. It's possible that you could put servo motors in here, but really super tight. So that's why I went looking for a way to move those motors somewhere else. So the plan is, I don't know if I've talked about this before, but these go together like this, right? So the plan is to run those Bowden tubes down and out at the elbow. So Dummy is going to be sitting on his speeder bike, his right hand holding the wheel, the steering wheel, turning. Left arm will be resting on an armrest. So what I'm going to do is I'm going to sneak all those Bowden tube and any other cabling from this side as well down into the armrest. So there'll be a hole in the armrest, and all that stuff will go down in the armrest, and those motors and electronics and whatever else are going to be hidden inside the armrest. And I'm also considering giving him an armband with the Rebel Firebird, the Rebel Alliance symbol on it, to cover all that up. So it'll make it look like he's just flying the colors of the Rebel Alliance, but it's actually covering up where those tubes and other electronic stuff go through. There's going to be some stuff coming, my current plan, there's going to be some stuff coming down this way as well. So there's going to be a lot going on at this elbow joint, and I'm going to try to hide it as best I can. For me, screen accuracy is less important than the ability to puppeteer. And I've talked about the puppeteering before. So I know that this joint is far from screen accurate, but it's going to allow me to do what I want to do as far as waving at the kids and things like that. So yeah, that was what that last video was. It was testing the joint, and the tests work, but I'm going to continue on. I've got some motors on order. They actually shipped already, and when they get here,
I don't know if I'm going to wait until I redesign this end or if I'm going to print a full one and then do a more rigorous test. I kind of think I'm going to do the more rigorous test. It's going to take me a long time to... This joint was literally a week in Fusion, like a solid week, to put all that together. So I suspect that this end is just as complicated, and I don't really have the full design yet. Anyway, that's it. Peace out. All right, so the plan for the automation moving the wrist is to use brushless DC motors. I have one here, this one little guy right here. So when I was doing research, so I knew I wanted to go with brushless motors. That was part of the plan. And when I was doing all the research, basically I know my limitations, and like my soldering isn't very good. I'm not very confident, like when you start talking about soldering little things. And so controlling a brushless motor, you have to have an actual motor controller specific for that. And you could do, like, you can get them from SparkFun, but the ones from SparkFun, you basically have to do all the assembly. I went with a company called Tiny Mover, spelled Tinymovr, Tiny Mover. I actually think it's really just a guy in Greece, Yanis is his name, and more than it is like a big company. But anyway, I'm pretty impressed with this little motor and the product line. So I bought, they're a standalone, right? So everything is already soldered and put together and calibrated, at least for this one. And so I got this one, and then I also bought a board, and I actually have it over here. So, and then I bought a gimbal motor, a GM 3506, which is this little one. So you see this one's a little bit smaller. So the Tiny Mover supplies the board, but then you buy the motor. So this one still needs to be calibrated and all that. So this one, I have done some movement testing, and that's the video that I'm going to show next. Hey guys, so I got this working, and so I'm going to demonstrate. So I've got a couple of 1, 2, 3 blocks with some marks roughly. So basically I figured on my previous test, just by moving the pulley by hand, that I'd be going about 180 degrees rotation. So this little motor isn't really going to have to rotate very much. So I wanted to do some repeatability testing. It looks like maybe it needs to be calibrated, because so this is 0 right here, so you'll note it's not quite straight up. This is 90 degrees, so that's pretty flat. Then going another 90 degrees, and then going another 90 degrees, and then going all the way around. So it's like the initial starting condition 0 isn't quite right, but then the other 3 look pretty good. So it's super quiet. It doesn't make any noise at all. And it can move really fast. I actually slowed it down because it was jumping off the surface of the desk when it was moving. So yeah, that's the BLDC motor. I'm just using a computer and Python to move it. So my next step is to figure out how to connect the radio control. I'm guessing I might need an Arduino in between, but yeah, so this little motor is going to move some part of his arm. I haven't decided what yet. I've got another brushless motor coming, which I think is a smaller footprint. So that one, depending on how the testing goes, it might be used for the wrist. This might be used for the arm, but anyway, it's pretty cool. There you go. Okay, so after thinking about this motor and what you just saw, I talked in the video about thinking needed to be recalibrated. But we're not going to do that, and not needed to do that after I thought about it. What's really important with this motor is reproducibility, meaning when you command it to go to, let's say, 90 degrees, that it repeatably each time goes to that place. And that repeatability is very good on this motor. I'm going to set the range of motion in software anyway. And so if it's not exactly straight up and down when I say 0, I can compensate for that in the software settings that I have to do anyway. And so I think because I'm just going to be taking a joystick and, moving the joystick and waving his hand around, I'm not going to need to go to the exact spot every time. So I think it's going to be perfectly fine, and pretty excited about how it's going. So that's it for this episode. Next episode, we'll continue on with the risk stuff. Maybe get into some automation, some Arduino programming. We'll see. There's got a lot. I actually have going to be recording a whole bunch of videos here back to back to back. So you'll probably be seeing me with this hat and this sweatshirt on for a lot of the next episode. So anyway, till next time.